Just a quick word about what Mott MacDonald is, just in case you don't know. It's a large multidisciplinary consultancy, about 14,000 people, and it's owned by the employees, and it's in about 140 countries. My company, Mott MacDonald Fulcrum, was bought by them about 3 years ago, and my background is low energy buildings and extending out into sustainable infrastructure. Today, I want to think about what we do about our future cities, and in particular, I'll be talking about heat, because that's what I know most about, and is a big issue. And the problem really is, we've got all the buildings, apart from a few, that we're going to build, and if we have to, and those new ones need to be zero carbon, which is easy to say, but actually rather difficult to do and imminent. So assuming we do manage to get all our new buildings to be zero carbon, then we've just got to deal with the existing ones. So here is a graph which is put together when we formed the UK Green Building Council at the beginning to try and get the new members coming into the Green Building Council to understand what they were actually dealing with, because a lot of them were from the commercial sector, big developers, very keen to improve their buildings, very good, very qualified, but I was trying to explain that the issue we actually have in the United Kingdom, which this graph is intended to show, and this is the purple area, is domestic buildings, and the fact they're actually rubbish, really. And we've had a lot of North Sea gas, so we haven't got any heat networks, and that's our problem, rather than the non-domestic, which is rather divvied up into lots of bits and actually relatively small. So our big issue in this country is to work out how to deal with our existing housing stock. And that curve, that's just a normal project. If you're going to do something, that's your spend and the rate you need to do things, so it's just a little curve. We stuck on the end to 2050 to hit our 80% reduction targets. And it shows really where it says today was in fact when they formed the UK Green Building Council. And if you look at that curve, you can see it needs to start getting quite steep, and currently it's still on the rather flat area. So this is about what's sometimes called secondary heat. It's the heat you need to warm your buildings up so that you're comfortable within it. The temperatures don't actually have to be very high. And if you think about a building, you're hotter than most of the surrounding surfaces. So the temperatures are pretty low. But we do heat them with central heating systems, which we burn fuel to make, quite hot water, which we then put into radiators and then warm places up. But it's not necessarily required. So this is about underground thermal energy storage, UTES, which is what is. So many cities, when you look at the profiles of what's going on inside any building, show that some are being cooled and some are being heated. And actually, quite often in big cities, that's happening at the same time. So the idea of secondary heat is to wonder whether or not the cooling of those buildings might become the supply for heating to the other ones. But obviously, that doesn't happen all the time, and there's a disconnect when you need it. But matching loads is about understanding what happens within buildings and when they need heating. And so if you look at this load profiles, you can see that there are opportunities, but they're not necessarily going to be simultaneous. And so you need some way of storing the heat. And you store the heat either in a very big tank or a very large phase change, or something very, very big if you're going to store between a season. That's a lot of heat. And I'm talking about storing from summer to winter and winter to summer. That's a large, large amount of heat. And it's very expensive if you build something to do that storage. So the suggestion is that we might be able to use the cooling of buildings, taking the heat out of a building. Effectively, they become Effectively, they become solar collectors. So they're passive solar collectors. So they get, generally, the big glass offices get too hot because the sun shines into their windows. Therefore, you take the heat out and you throw it away currently. You throw it away in the summer into the hottest time of year. The alternative would be to throw it away into the ground and then try and throw it away completely through a building in the winter. So, cool the building, heat the water up, put it into a warm store, use a heat pump, take the water out of the warm store, throw it, put the heat back into the building in winter, lose the heat that you collected in summer through the building in the winter, creating cold water which you put back into another store. So that's the idea of underground thermal energy storage. And it does happen, and it happens quite extensively. It was being developed probably most in the Netherlands, although it's now in Belgium and indeed in the UK. But in the Netherlands, sort of in Amsterdam in particular, it is the normal way of approaching heating and cooling a building. So there's several thousand now in the Netherlands which are using the aquifer as a store to heat. So basically they're sealed wells. So you drill one well, typical well is maybe 18 inches diameter, proper well size. You pass that water through a heat exchanger and put it back into another well, and then you connect the cooling systems up to the heat exchanger. And you create, cooling water comes out, initially it comes out the annual mean temperature, which is maybe 11 degrees initially when you get going. You take heat out of it to warm your building up. You make cold water which you put back into another well 50, 100 meters down the road. If the water isn't flowing through the aquifer, it stays where you put it. It can only really move by conduction or flow. So if there's no flow, it stays where you put it, basically. And you create a warm well and a cold well, and you just oscillate them. So when I say warm and cold, these are the mean sort of temperatures, 7 degrees, 15. So 15 is warm, 7 is cold. Those are the sorts of 7 degrees is the sort of temperature you would naturally use for a cooling system in a building. What this introduces is the idea that you might plan cities around thermal storage. So you might make it a good idea that architects put up big glass buildings as long as the heat that's collected from them is then passed to some old stock down the road. So maybe we need to start thinking about planning our cities around large thermal storage. Is it feasible? I've said it's regularly done in Holland, but is it feasible here? Well, that's the sort of a study looking at hydrogeology, looking at where it might be feasible in the UK. And you can see that it's not straightforward. The red in this case is where it is feasible. The green is where it isn't. So the question of whether it's feasible or not depends an awful lot where you are. Luckily, if you start to plot the big cities, you'll find they commonly occur in the red sections. So this is me then looking at trying to say, well, one of the problems we've had in the UK is that we never did get around to building heat networks, and how far away from something is it actually reasonable and economic to think about transferring heat. And in Denmark, where they have built an awful lot of central plants and distribute heat regularly, that is Copenhagen's current network, and it extends about 20 miles. So I would say they seem to think 20 miles is a reasonable distance to actually have a network over. So the question is, where are our power stations which are currently throwing all the heat away? Where are our new power stations going to be? And is there a way of connecting those two together, again, using thermal storage? And a lot of what I'm showing here is just speculative, but some of it is real. So this is the IEA. They also think it might be a good idea. It needs more research for sure, but there have been studies that have looked at where we are placing our new power stations, and if we're now going to be pushed towards gas, which looks like that's what's happening again, those can be quite small, they can be located much more centrally. And maybe we need to think of a combined heat and power in a sort of different way. So stop thinking of it as a small engine, but actually think of it more as a power station and what we do with the spare heat. And in terms of distribution, the reason I quite like the idea that we might use thermal storage is that the water you are distributing is close to the temperature of the surrounding Earth. So I'm talking about 7 degrees and 15 degrees being the store temperatures. The pipe work that you need to distribute that sort of water is water pipe work, and it's not insulated. So it's a lot easier to engineer and to install. And that's them installing it in Eindhoven University. And Eindhoven University is about 20,000 students. It's a campus which has grown up over quite a few years, and they are actively doing thermal planning there. So they are connecting in new buildings and old buildings as they redevelop them, and using what they know about the storage capacity of the ground to help them reduce the overall carbon impact of the whole area. So it's got currently 24 wells with a combined capacity of 3,000 cubic metres an hour. That's what we've got underneath London. As I say, it's not always convenient, and the trouble with using the ground as a store is you have to discover whether or not the ground you're standing on can actively be used as a store. You can do that by getting a desk study initially, and it will give you a good idea. But in London, for instance, a lot of it, you have to drill to know whether or not you're going to be able to do this. So there's a sort of upfront cost, which tends to mean that large thermal storage schemes like this have a minimum size of probably half a megawatt thermal. Megawatt plus becomes really economic. Interestingly, the developers in London are quite keen on this, of building new housing blocks, mixed-use housing blocks in particular, because it introduces the idea that they can sell cooling into their new housing blocks, and that's a good thing. So it does shift the ideas around a bit, because the alternative that I think we have is to completely overcloud all the buildings in our cities, and some of them are called St. Paul's and things like that, the equivalent. So maybe we don't actually want to overcloud those. We actually would like them to still need a lot of heat, but we need to get the heat from somewhere, and we have to reduce our carbon impact by an enormous amount. Biomass is okay, but biomass in the centre of a big city is a tricky thing to manage. And in the Amsterdam, this is modelling of the thermal stores underground. They've carried out quite a lot of modelling now, and they're starting to think of it at a utility level. So the water authorities are becoming involved, realising that they now have another business opportunity, which they didn't actually have before, because they have the knowledge about aquifers. They put the pipes in the road, and that's the sort of pipe they're used to using, and they have the right to distribute pipework through the streets, which are all those things are the things you need to maybe do this. And I went to a really interesting campus near Eindhoven, which is Philips High-Tech campus, which is run by an offshoot of Brabant Water, one of the local water utilities, called Heriot-Watt. And that is their business model. They now are developing long-term stores and energy supplies to non-domestic and domestic buildings. At the moment, it's largely non-domestic, but you could see it could become a way of using the water network, not just for distributing water, but for distributing energy. So it changes the pipe sizes, it means that things have to circulate, but it's not impossible. Again, another way of looking at it really. The big issue is domestic heat. And how we deal with that in the long term has to be what we deal with. Developing slowly are methods where overcladding of buildings becomes possible. And you can see that in areas where they're too spread out, that will be the approach you have to take. Reducing the energy demand is the first step. But I think if we want to make it happen fast enough, we really have to go to a more infrastructure-based approach. And I think it's around the concept of thermal planning. Seeing where you locate your heat-creating loads and your heat demand loads, and actually introducing that into the normal planning system. So you're required to show what your energy profile will be for your new buildings, and then it needs to be matched with the existing energy profiles. And the rate at which that approach has been growing in the Netherlands is quite steady. This goes up to 2008, but it's actually accelerated since then. And they're now doing studies which are looking at where it can be rolled out right the way across the whole of the Netherlands. And the various cities are thinking about how they fit into that process. And in particular, they're looking at how you might use these stores I'm talking about, the wells I'm talking about, typically 50 to 100 meters deep. But they're also looking at using old gas wells and digging down and drilling down into the deeper levels where the temperatures are already at 70 or 80 degrees, so that's sort of 3 kilometers down. And then potentially linking those two systems together to provide a heating and cooling system. And in particular, because they're in the Netherlands, they're using glass houses as their solar collectors, if you like. They're controlling the temperatures in sealed glass houses, so they don't have their windows opening and closing in the glass houses. They seal them up and control the amount of CO2 that goes into them, and they can take the heat out, and so they're actively cooling their glass houses to maintain temperatures, and then storing the heat, which is then put back into them. And this is a few examples of where that's actually being done in the UK now. This is National Maritime Museum in Greenwich. And this has probably got the first example of a retrofit aquifer thermal energy storage scheme in it. It's remarkably small, and it can fit very easily into the normal building services, which people are used to using, so heating and cooling in a standard way. And this is some figures for a supermarket, because when you start looking at storing heat, you realize you don't always have to store it between seasons. In a supermarket, essentially, they're producing too much heat all the time, or not all the time, but from their refrigeration, they're busy cooling when they actually need to be heating other things. So it's a very limited amount of store. But this company is ISAX, and it's developed short-term storage solutions with ground stores to enable them to recover heat and boost the efficiency of ground source heat pumps quite considerably. And this is an IKEA store. This does heat and cool that big building. It doesn't have a heat pump. It just puts coils in the air handling plant and either runs water from the cold well or from the hot well as is then necessary. So most of these big buildings, they're deep plan, well insulated, well sealed. They actually have a cooling demand, and most of the time. Interestingly, you can start to use that store between seasons for other purposes. And when you start to think of de-icing, you realize that's collecting cold. And in this airport they've just built in Sweden, they're using a variety of processes which are all based around the idea of low temperature heat store. So de-icing the runways, using the runways as large solar collectors, effectively connecting those back up with heat pumps to heat the buildings. Snow melting when they have problems. And this again is another ISACS scheme using large tarmac surfaces. This is a big school that's just been built, and it uses the tarmac surface as a solar collector. So it's 2 layers of pipes, basically. One layer a little bit deeper than the other. So there's a layer of pipes about a couple of feet down, layer of insulation, tarmac, pipes in the tarmac. The tarmac acts as a large, cheap solar collector and has the effect of de-icing, if you wish to, when it comes around the next year. But it's using roads, tarmac surfaces as large, cheap solar collectors. And that's an idea I think is worth pursuing. So thank you very much.